So in last video we discussed about two cases, that is how a charged particle moves in a magnetic field. So two cases we already did. The third one is, the first case was when the charged particle is moving in the magnetic field in a direction parallel to the magnetic field or anti-parallel. In that case no force is exerted, force becomes zero. In the second case we got that both are perpendicular to each other. So in that case we saw that the path followed was a circular path, right? Now this one, here the particle is moving in the magnetic field, making an angle which is more than 0 degree but less than 90 degree. That means, suppose if this is the direction of velocity of the particle, this is the magnetic field direction, so this angle is theta, where theta is any value between 0 to 90. Okay, so what will be the shape of the path of the particle? So for that let us focus in this figure. Okay, so here you can see, since the velocity is this one which has made an angle theta, what we have done is we have resolved this velocity into two components. So on resolving this velocity in two components, we will get one is v cos theta towards the base and this side is v sin theta. Now for v cos theta, this part, what we saw that this particle, this object, I mean the particle is released from here. So for v cos theta component, the particle will be drifted towards this. For which component? For v cos theta. So for v cos theta it will go some linear distance, alright, some linear distance. Now what happened is, for this particle, for this component v sin theta, see this component is perpendicular to the magnetic field, because magnetic field is this one B, which is along the x-axis. The magnetic field is along the x-axis. V sin theta is perpendicular to the magnetic field. So as we know that if the velocity is perpendicular to the magnetic field, for that velocity the object or the particle undergoes a circular motion. In the case 2 already we got this one. So if the particle undergoes circular motion like this, along with circular motion it is covering some linear distance also because of v cos theta. So what can be the shape of the particle? Shape of the path of the particle. The particle is going circular and going little linear. Circular, linear, circular, linear. So the path is a spiral path, means it is like a helix. We call it helical path, like a spring. Okay, so that means the resultant path of the particle will be like a helix, like this. Now the thing is that two very important things that you will remember here. One is, for v cos theta component it is going linear distance like this. Okay, and for v sin theta it is going circular distance, and together linear and circular is making the path helical. So I hope it is clear. Now as we know that since it is undergoing circular motion also, for circular motion which component is responsible? V sin theta. Some formulas will be same with the previous case, almost same, because if you remember in previous case we started with this mv square by r, that is the centripetal force, that one was equal to qvb, that was a magnetic force. Here what happened is, for which this formula we wrote for circular path. So here velocity will be replaced by v sin theta, because for v sin theta only the object is undergoing circular motion, rest thing will remain same. So if we do so, you can see here this one qvb, instead of that it is written qv sin theta b. This v is replaced by v sin theta. See, mv square by r, in place of v it is v sin theta, so mv sin theta square by r. Okay, in that way if you do the calculation, the value or the r, the expression for radius comes as this. Alright, In the previous case it was qv square by qb, mv square by qb, something like that, right? Anyways, this one is for r. So what happened is, from here sine theta 1, this one, no, v1 v will get cancelled, sine theta 1 sine theta will get cancelled, and ultimately this is the expression for radius. In the previous one, previous case, it was mv by qb only, sine theta was not there. Then if this is radius, time period, how did we calculate in the last case? Last case it was 2 pi r by only v. This time it is 2 pi r by v sine theta. Okay, so 2 pi r means, in place of this radius we substituted this value here. Okay, so v sine theta got cancelled. This is the time period. Once we get the time period, we can get the frequency by taking the reciprocal. We know this one. See, the expression for time period and the expression for this one frequency is same like the previous one. In this particular case, we will get another term that is called pitch of helix. If you remember the concept of pitch in screw gauge, you did the experiment, there you got this term pitch. So pitch means it is a linear distance travel after every circular motion, circular rotation. In every circular rotation it is going some linear distance. So this linear distance is the pitch. Okay, so we can say that here we have written pitch is nothing but is a linear distance. So we have the formula s is equals to vt. S means distance, linear distance, v is velocity, t is time. So here s means it is the linear distance, means it is pitch, p. V means for which component of velocity the object is going linear distance, for v cos theta. So in place of v, we will write v cos theta. Time means it is capital T, one time period, because after every circular rotation, or you can say in every circular rotation, how much linear distance it is going. So the time taken for every circular rotation is how much? Time period. So that is why this is time period, capital T. Okay, v cos theta, capital T means this value substituted, and finally we get this equation. So this is the expression for pitch. Okay, so this is about case number 3. Next we will go to next topic. This is called Fleming's left hand rule. This Fleming's left hand rule probably you got in class 10. So in Fleming's left hand rule, we take the first 3 fingers of left hand to represent 3 physical quantity. The index finger, the first finger or index finger, it represents magnetic field. The second finger represents current, and the thumb represents force. And how to keep all these 3 fingers in which position? Mutually perpendicular to each other. Okay, you know this one already in class 10 you got. So in this way, in this pattern, you have to keep the 3 fingers of left hand. Okay, it is given here, stretch the left hand in such that the four finger, that is the first finger or index, represents the central finger, and the thumb are mutually perpendicular. They should be mutually perpendicular in this way, isn't it? It is perpendicular. See, thumb and index is making 90-degree angle. Thumb and the second finger is making 90-degree angle. Index and the second finger is making 90-degree angle. Okay, so all are mutually perpendicular. In this way, if you stretch, then okay, the forefinger represents the direction of magnetic field, central finger represents the direction of current, and the thumb represents the direction of force. Alright, we will use this concept in other derivations, so just for this time you remember this law or this rule. One sum is given here, you can do it. See, a wire 12 centimeter, okay, just a second. Okay, a wire 12 centimeter long and carrying a current of 2 ampere placed perpendicular to the uniform magnetic field. Okay, the force is this much. Calculate the value of magnetic induction, that means B. B you are asked to find out. So since it is a current carrying conductor, magnetic conductor means it has a length. The length is given 12 centimeter. So which formula will be used? We have a formula already I gave you, that force is equal to just a second. Okay, now we have this formula where, yeah, what I was saying, this one, no? F is equal to I into L cross B. This formula already you got, right? Now the angle between the conductor and magnetic field is given 90 degree. How? It is given perpendicular. So if it is perpendicular, it should be actually ILB sin theta, like this. But here theta is 90. So if theta 90, sin 90 means it is 1. So only it will be ILB. So F equals to ILB. What we are supposed to calculate? B. So from this B will be F by IL. F by IL, right? Sin theta is 90 only. You can skip this part, sin theta. So then you substitute the value. Length is given 12 centimeter, convert it to meter. Current is given 2 ampere. Force is given 0.8 Newton. Substitute it, you will get the value of B, which is 3.33 Tesla. Alright. Then next one, this one. Next topic is Biot-Savart's law. Very important topic, Biot-Savart's law. Okay, let us see what is the statement of the law. Here what we have considered, we considered a conductor of arbitrary shape. Okay. In this conductor, we considered a small section, small length from B to A. The length is dl, which is a vector, suppose. It has a specific direction. And generally, the direction of dl, it is same with the direction of flow of current. So through this arbitrary shaped conductor, current is flowing this way. So what is the direction of dl then? This way. Okay. Then we considered a point P at this position. At this point, we are supposed to calculate the magnetic field. Okay. Suppose that magnetic field created at point P for this much length of the conductor is dB. Generally magnetic field is B, but since we have taken a small part of the conductor, this will create a small magnetic field, which is dB. Now according to Biot-Savart's law, this dB means magnetic field, it depends on few factors. The first factor is it is directly proportional to dl. This is directly proportional to the length of the conductor. First one. Next, this dB is directly proportional to the current through the conductor. Okay. Next, this dB is proportional to sine of angle theta. Theta is which angle? See, from dl is actually a very small length, but to make the diagram distinct, though here it is taken, here it is looking like little long, but it is not that much. dl will be a very small length. Okay. So from this dl length, the distance of point P where we are finding the magnetic field is how much? R, this one. So here this theta is nothing but it is the sine theta, means theta is the angle between dl is this way and R is this way. So angle between dl and R is how much? Theta. So this dB is another again proportional to sine theta. And the last factor is it is inversely proportional to the square of the distance. Distance is this one. Okay. So these are the four factors on which this dB depends. Now if you combine all these four, the equation becomes like this: dB proportional to ideal sin theta by r square. Now if This proportionality sign is removed by equal sign. We'll get one constant here, that is k. Okay, now this constant k is nothing but, for this particular case, it is mu naught by 4 pi, where mu naught is called the absolute permeability of free space. It is like that permittivity of free space you got in electrostatics. This is permeability, which determines the magnetic effect of a medium. Suppose you see here dB and mu, how they are proportional directly. So if we consider any such medium where the permeability is more, then the magnetic field strength in that medium will also be more. Or in simple word, though mu naught means it is the permeability of free space or vacuum, it will have a specific value. But if you take some other medium, then the value of mu naught, we will not write mu naught, then we will write mu. Mu is the permeability of that particular medium. So permeability is a property of a medium which determines the magnetic field strength of the medium, in the medium, magnetic field strength in the medium. Okay, that means B in the medium. Anyways, so this is the formula that we got from Biot-Savart's law. Alright. Okay, another thing, the value of mu naught. The value of mu naught in SI unit is 4 pi into 10 to the power minus 7. Unit is this one, Tesla meter per ampere. Or Tesla meter, it is also given as like this, Weber per meter per ampere. Weber means magnetic flux. We'll discuss about it later on. Okay. Anyways, you write this unit better. Tesla meter per ampere. Okay. Then, if mu naught is having this value, if you substitute it here, the value of mu naught, then this 4 pi and this 4 pi will get cancelled. Ultimately, what we are getting in this place, 10 to the power minus 7. Now remember that this value is applicable only for air medium, not for other medium, because mu naught, the value of mu naught is this one. This is only for air, because mu naught means air only. It is for air, no, free space or vacuum. Okay. Now this is Biot-Savart's law. This one will use in many cases, this equation. Another thing, that this Biot-Savart's law, it is in scalar form here. We can write it in vector form also. Simple one, just remember that for vector form, dB, we'll write dB vector. Current in right hand side, in left hand side, if dB is a vector, in right hand side also something should be a vector, right? At least one thing should be vector. So see here, current is not a vector. So only vector in this side is this one, length, that is dl, r, these are vectors, length. Okay, so to represent this one in vector form, what is done, this whole thing, this one, it is multiplied with r cap. What is r cap? It is a unit vector along vector r, unit vector. And since it is multiplied r cap, it is not making any difference in the magnitude, because unit vector means its magnitude is how much? 1. So if its magnitude is 1, if you multiply the whole equation with 1, the magnitude is not getting affected. So we can easily do that. R cap we are multiplying, and once we multiply r cap, now you see in this place I is a scalar, so can we say this one, dl will be there, I is scalar. Okay, so dl, then sin theta, and with that what we have, r cap. So this is like ab sin theta. A means dl, b means r cap, sin theta. So ab sin theta means, can we write a cross b means dl cross r. I was already there, so I will be there only. Mu naught by 4 pi was there. Okay, it will remain as it is. R square was there, remain as it is. Here, since it was sin theta, we can write dl cross r cap. And once we write it, the right hand side also becomes a vector, because it's a cross product of two vectors. Cross product of two vector is what? Another vector. So this is the vector form of Biot-Savart's law. Okay, so I hope it is clear. Alright. In some book, this thing, this one, it is written like this also. Okay, I'll just show you. dB is equal to vector form. Okay, mu naught by 4 pi will remain as it is. Here, okay, I will remain as it is, scalar. Here it is written dl cross, in place of r cap it is written only r vector, and below r cube, not r square but r cube. Why so? If you remember, in class 11 we got this concept. Vector r is equal to r into r cap. So from this, r cap is equal to what? Vector r by r. So in this place, r cap, if we substitute this thing, that is nothing but this one only. See, r vector, this one, and this r, it is getting multiplied with this r square, making it r cube. This is also vector form of Biot-Savart's law. Okay, so I hope this much is clear. Then in next class we will in next video we'll discuss about application of Biot-Savart's law. One application we'll discuss.